Hello my dear students, how are you all? Welcome to Deeksha, Karnataka, and today I am going to discuss the question blueprint from the chapter, MCQ blueprint from the chapter Dual Nature of Radiation and Matter. And as you can see in the Dual Nature of Radiation and Matter, okay, the total weightage of chapters is 5. Out of that we are going to get 2 objective type questions. 2 objective type questions means either we will be getting 2 MCQs, or we will be getting 1 MCQ, 1 fill in the blanks type question. So this is a important chapter in terms of MCQ. So if you want to master the MCQs, definitely you have to watch this lecture. And other than that, we also have a 3 marker question. There will be no 5 marker question coming from this chapter. So let us start with today's session, obviously. So this is the paper. I will wait for some time, more students will join, then I will start. So till then, tell me, how are you all? How's everything? So by the way, dual nature of radiation and matter also have some historical important experiments that you may have heard of. Okay, the main experiment that happened in early 1800, late 1800 and early 1900. One of them was first of all Millikan's oil drop experiment. After that, there was one more experiment by Henrik Hertz. After Henrik Hertz experiment, J.J. Thomson discovered electron, and he said that all the charges which are there are basically electrons, and he termed that he first used the term electrons, and then from there on photoelectric effect, then we have the scattering experiment. Everything took place from that point of time. Even though the theory of photoelectric effect came a little late, but it was first done by Leonard and Hallwach, right? So we will start with the session today. The cathode ray particles are same as dash. So protons, electrons, alpha particles, or neutrons. So cathode ray particles are same as electrons. Cathode ray is same as electron. They are not any electromagnetic ray. Okay, cathode ray are basically electrons. So correct answer is electrons. Okay, so correct answer in this question is electrons. Next is, in discharge tube, the cathode ray particles travel with the speed of. Even though they are marked easy, they are not so easy. If you are someone who tend to remember a lot, then it's fine. Otherwise, in discharge tube, the cathode ray particle travel with the speed of. So cathode ray tube, the discharge particles travel with the speed of 0.2 c. Okay, 0.1 to 0.2 c. 0.2 c translates to be 0.2 into 3 into 10 to the power of 8. That is 0.2 into 3 is 0.6. So 0.6 into 10 to the power of 8, or 6 into 10 to the power of 7. So 6 into 10 to the power of 7 is the correct answer. So here we will mark it 6 into 10 to the power of 7 meter per second. Obviously, unit of speed is meter per second. They do not travel with the speed of light, by the way, careful. Okay, they do not travel with the speed of light. Now let us answer question number 3. The minimum energy required by the electron to escape the metal surface is called, what they are called? Work function, ionization energy, stopping potential, or field emission. Quite easy. Hello Komal, how are you? Yes, question number 3, you answered it correctly. Work function. The minimum energy required by the electron to escape the metal is called work function. Now this is very interesting. Alkali metals emit electrons when they are illuminated by infrared waves, visible light, radio waves, or microwaves. Now remember that out of all these, whoever has the highest frequency should be the answer, because if it is possible in lower frequency, then it is also possible in the higher frequency, definitely. Okay, if you increase the frequency, for example, if it is happening, say for example, if radio waves are able to give the emission, then it is also possible for microwaves, visible light and infrared. So radio waves cannot be the answer. Okay, so you have to choose the answer with the highest frequency in the given question. 4B, Subbu also answering 4B. Yes, visible light is highest frequency amongst all four, so visible light is the correct answer for this question as well. Now next question. Heavy metals like zinc and cadmium emit electrons when they are illuminated by infrared, microwaves, ultraviolet, visible. Again, the highest frequency. So you have to identify the highest frequency amongst them, because if it is possible for lower frequency to give you the photoelectron, definitely the higher frequency will also give you the photoelectrons. Okay, so if higher frequency should be your cutoff. Komal Kaushik is saying 5C. Yes, ultraviolet is higher than anyone else here, so ultraviolet will be the answer. Okay, so cadmium, zinc, etc. They heavy metals give photoelectric effect in ultraviolet light in the first experiment. In the first experiment, when it was conducted by Holwaz and Leonard, they used zinc and ultraviolet ray to observe photoelectric effect. Another interesting question, question number 6. The graph of photoelectric current versus intensity of incident radiation. Nu is greater than nu naught. Okay, so it is very essential. If it is other way around, so if nu is less than nu naught, you will not get any photoelectric effect, any visible photoelectric effect. Nu refers to frequency of light. Okay, so when the frequency of incident light is greater than the threshold frequency, then what is the graph of photoelectric current with intensity of incident radiation? 6C. Komal and Subbu both are saying 6C. What is 6C? Straight line passing through origin. So if you remember the graph, it is a graph like this. It is a straight line graph which passes through the origin. That means this will be a straight line graph passing through the origin. So correct answer is option C. There are many graphs, by the way, so you have to be careful. Photocurrent versus frequency graph is a straight line passing through the origin. Okay. Photocurrent not by intensity, photocurrent versus intensity of light. Okay. Next question number 7. Photoelectric effect, the time lag between the incident of light and the photo emission is of the order of. In photoelectric effect, the time lag between the incident light and electron emission is of the order of 10 to the power of minus 9, 10 to the power of minus 7, 10 to the power of minus 5, minus 4, 10 to the power of 9. Komal Kaushik is fastest finger first. So yes, 10 to the power of minus 9 is correct. Okay, it is almost instantaneous. That's why we say photoelectric effect is instantaneous, because the time lag is very small, right? Next is the de Broglie wavelength of a moving particle is independent of dash of the particle: charge, mass, speed, momentum. Now what is de Broglie wavelength? If you remember the formula, de Broglie wavelength is given by lambda equals to h by p. Lambda equals to h by p. H is a constant, Planck's constant. P is the momentum of the object. So which of these it is independent of? So Subbu Yadav answered 8A, and Komal Kaushik also answered 8A, because mass into speed is actually the momentum. Mass into speed is actually momentum. So definitely mass and speed, even though in the formula it says h by p, mass and speed cannot be independent, because mass into speed itself is momentum. That means correct answer should be charge. It is independent of the charge. Next question, easy question. Emission of electron from a metal surface by suitable heating is called photoelectric emission, thermionic emission, field emission, secondary emission. Now answer the question number 9. Easy question. emission of electrons from a metal surface by suitably heating. So what is the other name of heating? Yes, 9b, thermos. That is all related with heating, right? Thermal properties of matter, okay? Thermal kinetic theory of gas. So basically thermo means it basically represents something with related to heat. So that's why it is heating effect is called thermoionic emission. Heating emission is called thermoionic emission. In photoelectric effect experiment, if only the frequency of incident radiation is increased, then the maximum kinetic energy of photoelectron decreases, the stopping potential increases, the photoelectric current increases, the photoelectric current decreases. Okay, if the frequency of incident radiation is increased, only nu is getting increased. So what will happen to the total system? That electrons are coming out, maximum kinetic energy photoelectron decreases, stopping potential increases, the photoelectric current increases, photoelectric current decreases. Very interesting question. Subbu Yadav is saying 9b. Yes, correct. Komal Kaushik is saying 10b. What is 10b? Maximum kinetic energy of photoelectrons increases with increase in frequency. So this is not correct. Okay, decreases is not correct. Now stopping potential increases, we'll come back to that. The photoelectric current increases is not correct. Photoelectric current depends only on the intensity. It does not depend on the frequency. Photoelectric current is directly proportional to intensity. Same, photoelectric current decreases is also incorrect. So frequency, increasing frequency means the kinetic energy increases or the stopping potential increases. Okay, increasing the kinetic energy means you need more potential to stop the electron. So stopping potential increases is the correct answer. Now which of the following experiment proved that the charge is quantized? Which of the following experiment proved that the charge is quantized? Millikan's oil drop experiment, de Broglie experiment. De Broglie did not do any experiment, by the way. Alpha particle scattering experiment, Hertz experiment. Only two relatable experiment over here. One is Millikan oil drop or Hertz experiment. Alpha particle scattering is related to atom, right? It is nothing to do with the photoelectric effect. So Komal Kaushik is saying 11a, Millikan oil drop. Yes, Millikan oil drop is the correct answer. Millikan oil drop is the correct answer. So Millikan oil drop actually proved. Yes, Komal also answered 12. No. Let's look into the question number 12. So this is the easy question. Millikan's oil drop, either Millikan's oil drop or Hertz experiment. Hertz actually proved the Hertz experiment also proved the wave nature of particle. Okay, but mainly it was also involved in photoelectric effect as well. The particle behavior of light was confirmed by the following experiment. Let's see. Here we have experiment number 1, A.H. Compton on scattering of X-rays from electrons, Albert Einstein for photoelectric effect, Millikan for charge of an electron, J.J. Thomson for discharge tube experiment. Okay, which of the particle behavior of light was confirmed by which following experiment? So not only one experiment, you have to identify multiple experiments. They have listed something 1, 2, 3, 1, 2 and 4, 2, 3, 4, all of the above. Let's see who can answer this. Subbu Yadav and Komal Kaushik both are saying 12A, that is 1, 2 and 3. So remember that J.J. Thomson's experiment was nothing to do with the particle nature of wave. He did the measurement of E by M for an electron, mass per charge of charge per mass of electron. That's what he's doing. But Compton's alpha X-ray scattering and Einstein's photoelectric effect are the main reason, but Millikan also showed that charge is quantized. So in one sense, Millikan and Albert Einstein's experiment are related to each other, because Albert Einstein also said that light behaves like a quanta, that is a fixed charge. So that's why Millikan's experiment and Einstein's experiment are partly same, but alpha scattering and Einstein are the major part, so you should not skip those. So option A is correct answer in this given case. Okay, in case you see only the 2 is given, Millikan oil drop is not given, that is also correct answer. Photon energy is independent of intensity of radiation, frequency of radiation, wavelength of radiation, wave number of light. So photon energy of a photon is generally given by h nu, right? So nu is frequency, so what all it is independent of. 13A, intensity of radiation. Yes, correct answer. Good job, both of you, good job. Intensity of radiation is something which is not related to energy of photon, because frequency, wavelength and wave number, they all are interrelated. Okay, they all are interrelated. So frequency and wavelength equals to C by nu. Okay, so wavelength and frequency are related. Similarly, wave number is related as 2 pi by lambda. So everything is related. So that means these three quantities are actually siblings. They are interrelated. So you cannot say that it is independent of wave number. This is a very smart question. Okay, so E is equal to h nu, but intensity does not appear anywhere. So you can easily skip that. Now next is, in a photon particle collision, which of the following is conserved? In a photon particle collision, which of the following is conserved? Only total energy is conserved, only total momentum is conserved, both total momentum and energy are conserved, neither total momentum nor total energy is conserved. Very interesting question. Let's see who can answer this first. Tara Devi is saying, sir, but oil drop experiment was done by Millikan, not J.J. Thomson. Yes, obviously, oil drop experiment was done by Millikan only. Okay, Thomson did a cathode ray tube experiment where he measured the E by M of an electron, right? But Millikan's oil drop experiment is related to Einstein's photoelectric effect. Even photoelectric effect experiment was not done by Einstein. He did the theory background. Okay, it was done by Holbach and Leonard. Okay, theoretical explanation was given by Albert Einstein. Okay, experimental observation was done by Holbach and Leonard, and some partly by Hertz as well. 14C, both momentum and total energy. So as you know, energy and momentum may not be conserved in some cases, but energy has to be conserved. But in this case, momentum and energy always conserved, so that's why momentum and energy are conserved. Okay, now macroscopic particles in our daily life do not show wave-like properties because they are not associated with waves. Their wavelength is extremely high, their wavelength is 0, their wavelength is negligibly small. Okay, so very interesting question. I will give you a perspective after that. So Komal Kaushik is saying 15D, negligibly small. Now tell me, what is the difference between wavelength is 0 and negligibly small? Negligibly small means almost 0, but still, so you have in mathematics you have learned something called limit x tends to 0. So limit x tends to 0 means x is actually not 0, but it is very close to 0. So their wavelength negligibly small means, for example, if you calculate the wavelength of me, okay, it will be of the order of such a small wavelength, I will not be able to do anything. Okay, my wavelength will be very, very small. Okay, so wavelength is negligibly small is more accurate than 0, which is practically 0, but still it is not theoretically, you cannot say exact 0, even 10 to the power of say minus 34. Okay, 10 to the power of minus 34 is a very small number, but that is not 0. So that's why negligibly small is more accurate than 0. Okay, do not write 0 blindly. Negligibly 0 or negligibly small is more correct than 0, even though mathematically, practically both are same, but in terms of physics, negligibly small is more accurate. So that's a interesting thing. The gathering of and focusing mechanism of light by eye lens is described by wave nature of light, particle nature of light, only A, only B, both A and B, neither A nor B. Gathering and focusing mechanism of light by the eye. Gathering and focusing back. Okay. Yes, correct, Komal. Gathering and focusing. Gathering and focusing. Gathering and focusing. Okay, they are saying only A, that is wave nature. Now let us take the next question. I will answer it later. Absorption of light energy by retina of eye is described by wave nature of light, particle nature of light. Now answer the 17th question. Wave nature of light, particle nature of light. Let's see who can answer question number 17. Gathering and focusing, you are saying wave nature. Then what about absorption? Come on, quickly. Only B, particle nature of light. Yes. So our eye actually uses both property of light. Okay. So wave nature is basically when the light ray is falling on a lens, eye lens, right? We know that it works like a lens. So when the light ray is falling on the eye, it is basically gathered and focused using normal wave nature of light. Okay, so 16A is correct. But when it is fallen on the retina, okay, the retina absorbs them as a quanta of energy. The retina absorbs them as quanta of energy, and then it sends electrical signals back to our brain, and brain analyzes that signal, and thus we can see. Okay, that is the major thing. Without the wave nature and particle nature, both nature together, it is impossible for us to see anything. Okay, so because the light has both properties, okay, particle nature as well as wave nature, so that's why we are able to see. But the gathering and focusing part is done by the wave nature, whereas the collection part, where retina absorbs the energy, is done by the particle nature of energy. Particle nature means quanta, right? So quanta of energy is getting absorbed by our retina. It is absorbing quanta by quanta. Now let's see. The slope of the graph plotted between kinetic energy in joules of photoelectrons and frequency in hertz of incident radiation in photoelectric effect is H, E, H by E, E by H. Let's see. There is one more question in slope, I think. One more question in future. Yes. This is slightly different. So the slope of the graph plotted between kinetic energy in joules of photoelectrons and frequency in hertz of incident radiation in photoelectric effect is given by. So what is the equation? Kinetic energy K max equals to H nu minus phi naught. Right? Phi naught is the threshold frequency. So what is the slope of this equation? You can write this equation as y equals to hx minus c. Okay, so y is equal to hx minus c, or in other term we can say that it is actually equal to mx plus c. What is the meaning of this m? This is the equation of straight line where m gives you the slope. We know in mathematics equation of straight line, right? So if you compare these two equations, you will see that y is given by k max, whereas m is given by this h. Simple. It is not h by e, but actually h. The slope is h. Yes, correct. Komal answered. M is slope. Yes, m is slope. straight line equation. Compare whenever you are confused, try to remember the equation, and from there try to construct y is equal to mx plus c. From there you can say, okay, this is the intercept is phi naught, and this is y, this is x, that means this must be the slope, which is h. We will see one more question based on the same concept. The saturation current during photoelectric emission, nu is greater than nu naught, depends on frequency of incident radiation, intensity of incident radiation, speed of incident radiation, wavelength of incident radiation. We solved one more question similar to that. Now answer this. So saturation current only depends on intensity. It is independent of frequency. It only depends on intensity of incident radiation. So 19B is correct. Yes, Komal, you are again correct. Einstein's photoelectric equation was experimentally verified by Heinrich Hertz, Max Planck, J.J. Thomson, R.A. Millikan. So tell me the answer. This is also very, very important. Einstein's photoelectric equation was experimentally verified by Heinrich Hertz, Max Planck, J.J. Thomson, or R.A. Millikan. (20D) R.A. Millikan, yes, that is the quantization principle. So quantization principle was experimentally verified by Millikan's oil drop experiment. That's why it is a part of the trio of experiment, which is basically determined the photoelectric effect. Now this is the question. The value of E by M was found to be dependent on nature of metal, independent of nature of metal, dependent on the gas in the discharge tube, independent on the gas in the discharge tube. So it was a discharge tube experiment which was done by J.J. Thomson. In the experiment he determined the E by M for electrons. Okay, don't worry, if we once this session is done, all the MCQs are done, we will also going to solve the fill in the blanks for this chapter. Okay, because fill in the blanks question will also come from this chapter, so we will cover that as well. So value of E by M was found to be dependent on nature of metal, independent of nature of metal, dependent on gas in discharge tube, independent on the gas in discharge tube. So what is the correct answer? 1 and 4, 2 and 4, 1 and 3, 2 and 3. So first of all, electron divided by mass of electron is does not depend on metal, does not depend on gas, so it is both independent. That's why it is found that it is a something new, a particle, a new particle. Okay, and that particle was termed as electron. Thomson first named it as electron. This is the first particle that was discovered by any human. Okay, later on proton and neutron was discovered. First particle was discovered by Thomson and he discovered electrons. Okay, so 21 will be both 2 and 4, so option B is correct. Yes, you are correct. Right, now next question. The following statements are related to photoelectric emission. Statement number 1. Photoelectric current is directly proportional to intensity of incident radiation. Photoelectric current is directly proportional to intensity of incident radiation. Statement number 2. Maximum kinetic energy of photoelectron increases with the increase of frequency of the incident radiation. Both are true, both are false. One is true, 2 is false. One is true, 1 is false, 2 is true. 1 is true, 2 is false. Easy question. Nagraj came back after some time, so he says 21A. Yes, both statements are exactly correct. So it is photoelectric effect is directly proportional to the intensity and kinetic energy is directly proportional to the frequency. Okay, so now we are doing the HOTS question. So these are all considered to be difficult question. Let's see this question. The slope of straight line obtained by plotting stopping potential V naught versus frequency of the incident light in photoelectric effect experiment is phi naught by h, h by e, phi naught by h, h by e square. So both option A and option C are given same. I think what they tried to give you is h by phi naught. Okay, phi naught by h, or h by phi naught, h by e, or h by e square. Very interesting. So let me give you a hint. We know that kinetic energy max is actually h nu minus phi naught, right? This is the equation. Now what is K max? So if stopping potential is given by V naught, then the kinetic energy, the maximum kinetic energy is given by charge of an electron times the stopping potential. This is the maximum value of kinetic energy. That must be equals to h nu minus phi naught, or V naught equals to h by e into nu minus phi naught. So again our old equation, y equals to mx plus c. So you can find that intercept is minus phi naught, phi naught by e. The intercept is minus phi naught by e, whereas the slope is h by e. So this is the equation. V naught is y, nu is x. So from here we can say that the slope of the graph is h by e. Slope of the graph is h by e. Yes, Komal, Subbu, both of you are correct. Nagaraj also answered, yes. Now let's see question number 24. This is also very interesting. In a photoelectric experiment, the wavelength of incident radiation is reduced from 600 angstrom to 5000 angstrom, 6000 angstrom to 5000 angstrom. Then maximum kinetic energy of the emitted electron will decrease, the stopping potential will increase, the maximum speed of emitted electron will decrease, the value of work function of the metal will increase. Which one is correct? Let me erase this. Very interesting question. So the wavelength of radiation decreases from 6000 to 5000. Then what will happen? Maximum kinetic energy will decrease, stopping potential will increase, maximum speed of the emitted electron will decrease, the value of work function of the metal will increase. So saying 24b. So let me explain why it is 24b or something else. So first of all, kinetic energy max is basically, we have seen that given by h nu by nu naught. Okay, so what is h nu? H nu means hc by lambda. Okay, hc by lambda minus phi naught. So as you can see, the wavelength is decreasing. So wavelength decreasing means the denominator is getting smaller. So that means kinetic energy must increase. So if wavelength is decreasing, then kinetic energy must increase. Okay, so maximum kinetic energy electron will decrease. It's not correct. Kinetic energy of electron is increasing. Okay, so what about the speed? Kinetic energy means half mv square, m is constant, so emitted electron will also increase. This is also not correct. So energy is increasing. Energy increasing means the speed will also increase. The value of work function will increase. Value of work function for a given metal is constant, it does not change, so it will not change. So from the method elimination we can say stopping potential will increase, or mathematically we can say that K max is actually EV naught. So from here also we can say that if lambda decreases, then V naught must increase, right? So V naught is increasing over here. Okay, now last MCQ. This is the last MCQ. Some of it is not scrolling. Let me check. Which of the following figures represents the variation of de Broglie wavelength lambda of a particle with its momentum p? Which of the following figures represents the variation of de Broglie wavelength lambda of a particle with respect to momentum p? Okay, interesting question. So what will be the answer? 25D. Komal Kaushik is saying 25D. So why 25D? Let us understand. The de Broglie wavelength is given by lambda equals to h by p. So we see that lambda is inversely proportional to the momentum, and inverse proportional graph means it is always a non-linear graph and it is decreasing with increasing p. So as momentum increases, the lambda decreases, so that means we get a very smaller lambda, and option D is correct. Okay. And remember that this is the most common pattern of the graphs asked in kcet, never asked in board exam, but who knows, maybe this year they will ask question on from this graph as well. Now let us time to solve the fill in the blanks as well. So fill in the blanks, first question you have to type in the answer, okay? Type in the answer, no more option, you have to type the answer. The phenomena of photoelectric emission was discovered by kinetic energy, de Broglie, Henrik Hertz, intensity, wave, particle, photon. Now here should be a name, and we only have two names, de Broglie and Henrik Hertz. So who will be the answer? Yes, Kaushik is saying Henrik Hertz. So I don't like to write the entire name, so I will write H Hertz. And he is the same person on which the unit of frequency was named after. Okay, this Henrik Hertz is the same person on which the unit of frequency was named after. The stopping potential is the measure of dash of liberated electrons. Stopping potential, so this is done, so you will mark it, this one is completed. Stopping potential is the measure of dash of liberated electrons. Kinetic energy, de Broglie, intensity, wave, particle, photon. Yes, correct. Stopping potential is the measure of kinetic energy, not only energy. Okay. Wavelength associated with material particles in motion is called dash wavelength. Wavelength associated with material particles in motion is called dash wavelength. Subbu came back and answered 24B. Yes, Subbu, I think your video is slightly lagging. Correct answer, Subbu. Now answer the fill in the blanks. Wavelength associated with material particle is called dash. Komal Kaushik already answered de Broglie. Okay, and if you wondering why, de Broglie is the name of a person. Generally when we say any name, we start with a capital letter. Okay, we start with a capital letter. For example, Albert Einstein, Albert starts with capital A, Einstein also starts with capital E, right? So name and surname, we generally have this kind of thing. But why de Broglie's name is starting with small letter? Because his full name is Louis de Broglie. Okay, if you pronounce in current English, it will be Louis de Broglie, but he is a German, so his name is Louis de Broglie. Okay, the S remains silent. Okay, Louis L capital L is capital, and he had a weird middle name. Though the Germans, they generally have weird middle names, and that was named in small letters. Okay, Louis de Broglie was his full name, and de Broglie is basically his middle name D is the middle name and it was written in small letter. That's why it is, the name is starting with small letter. Very interesting story. And if you are wondering, Louis de Broglie was actually a humanities student. He was studying history. Okay, suddenly after the discovery of Einstein, the photoelectric effect and the corresponding explanation, there was a lot of discussion. He was studying in one of the premier institute in Germany, and there after the discussion he actually proposed that if wave is behaving like a matter, then matter should also behave like particle. That was his hypothesis. So that's why it is called de Broglie's hypothesis, and later on he developed the theory for it and he became a physicist from a historian. Okay, so he could be a famous historian, but fortunately he came to physics and give us this wonderful theory. The Maxwell's equation of electromagnetism established the dash nature of light. Okay, wave nature. Yes, Maxwell's equation, 4 equations together, they give the wave nature of light, and that is also correct. Okay, Maxwell's equation actually gave the wave nature of light. In interaction with matter, light behaves as if it is made up of packet of energy called, so kinetic energy is done, de Broglie is done, wave nature is done. So now let us see. In interaction with matter, light behaves as if it is made up of packet of energy called, okay, Komal Kaushik is answering fast. It is called photon. Photon is packet of energy. Okay. Next is, during photoelectric emission, the number of photoelectron emitted is directly proportional to dash of the incident light. So it is directly proportional to intensity of incident light. Yes, intensity. Correct. Photoelectric emission is based on the law of dash, conservation of dash. Okay, photoelectric emission is based on the law of conservation of dash. What is the answer? Energy. Yes, correct. It is the based on the conservation of energy. Okay, we have some small to answer type questions. If you want, I can give you basic ideas on what factors does the work function of the metal depend. So work function of a metal depends on which factors? Tell me. Can someone answer this? On what factors does work function of a metal depends? Who can answer? Who will be anyone who answering will be man of the match. Okay, number one is material. Obviously the material, type of the material that we are using, whether it's a heavy metal like zinc, cadmium, or it's an alkali metal like lithium. So that is one type, material. And second, material and temperature. Material and temperature, on these two factors the work function depends. Okay, higher the temperature, generally electrons have already gained some extra energy from because of the temperature, so it requires less amount of extra energy to be free, right? So material and temperature are the two answers for this question. Define electron volt, express its value in SI unit. So I am leaving it for you. Electron volt is easy, the energy gained by an electron to accelerate in an 1 volt potential difference is called electron volt. The SI unit, the value of SI unit you can calculate, it's easy. Writes Einstein's equation of photoelectric effect and explain the terms. Very common question. Okay, already we have written 2-3 times. Explain the Hertz observation in photoelectric effect. That is also very common. Okay, it is an instantaneous process. Okay, and what else? It increases with the current. The maximum kinetic energy increases with frequency, whereas the saturation current increases with the intensity of light. Those are Hertz observation. Showing graphically how the photocurrent varies with stopping potential for different frequencies but same intensity of incident radiation. So stopping potential is, so the graph will be like this. Because same intensity you will get, this is for frequency nu1, this is nu2. Okay, nu1 must be greater than nu2. Okay, this is say V01, this is V02. Okay, so higher the frequency, higher the value of stopping potential. Photocurrent depends only on intensity, so this is the correct graph. Okay, show the variation of stopping potential with frequency of incident radiation graphically. So this one already we have done. Okay, show the variation of stopping potential with the frequency of the incident radiation graphically. The stopping potential versus incident radiation is like this. Okay, this is the cutoff threshold frequency. Okay, and it is a straight line. This is stopping potential and this is frequency. And these are known as the threshold frequency of the given material. An alpha particle, proton and electron are moving with equal kinetic energy. Which one of these particles has the longest de Broglie wavelength? Give reason. Okay, so very interesting question. Alpha particle, proton and electron, all of them are moving with equal kinetic energy. Kinetic energy is equal. So which one of them will have the highest or longest de Broglie wavelength? So for that we will use one shortcut, that is the momentum is given by square root of 2m k. K is kinetic energy. Okay, momentum and kinetic energy can be related to this formula. This one you have learned in your PU1, and this formula is very important in this chapter, especially in kcet exam. Okay, there are a lot of cases, cases. If you use this formula, the problem can be solved easily. Okay, so alpha particle, proton and electron. So we know that alpha particle has highest mass, so P alpha must be greater than that of P proton, and that must be also greater than P of electron. So electron has the smallest momentum. Now de Broglie wavelength is given by h by P. Whoever has the highest momentum should have the smallest wavelength, right? So highest momentum is by alpha particle, so alpha of alpha particle must be less than that of alpha of proton, and this must be less than that of lambda electron. Okay, so this is the correct answer, and you should start by this equation. Okay, and then you should explain that the mass of alpha particle is more than that of proton, and then it is also more, mass of proton is more than that of electron. So that means their momentums are oriented like this. From here we can say that lambda is proportional to h by P. So that means lambda alpha is less than that of lambda P, less than that of lambda E. This is also a kcet level question that can come as an objective question in kcet. Komal Kaushik is saying material, purity of material or type of material. Purity and type, okay, this is same as material. Okay, purity is one sense, okay. So material is one. Okay, purity type can be considered as one. Second is temperature. Okay, type of material used. Type of material itself includes the purity or impurity. Okay, impure material, suppose I say I use a impure zinc, that means it's a different material compared to a pure zinc. Okay, that means Material, generally we oxidize the surface of zinc so that it can easily emit the electrons. Oxidizing the surface of the zinc is also considered to be coming under material. Okay, so material and temperature are the two options, right? So it's time for me to close this session today. I really enjoyed the session with all of you. I hope you also enjoyed today's session, right? So I'll be back with a new lecture very soon. Till then, bye, see you and in a later live video.